Okay, welcome to our very last video for MS100. And today I want to talk to you as a continuation of IPMT and PPMT, or interest and principal payments, about amortization. So, what you're looking at on the screen is an amortization schedule. Okay, so it looks to you like a whole bunch of information, right? All these different things going down. And what does all that mean? Well, let me spell it out for you with this one already done, and then I will show you how to solve it, just like what you'll have to do on the homework. So we'll have a blank one here, where we'll go in and solve that out. So we're talking about loans. And in this particular case, we're talking about a mortgage. However, it doesn't have to be a mortgage. It could be anything, a small business loan, a car loan, a personal loan between two people, as long as it's interest bearing. So what you're seeing here is a detailed explanation of every single payment of the loan from the first to the very last payment. All right. So here's how it works. Say you have a $250,000 house financed at a very generous 3.75% annual interest rate. Well, you know on a mortgage, you're going to pay that back monthly. Okay, so we'll say today, September 28th, 2017, you're going to make your first payment on that mortgage, and it's a 30-year fixed mortgage. Okay, so based on the things we've learned in the class, you could calculate the payment as 1,157.79 per month. Okay. Now, based on the last video that we just had, you've learned that this 1,157 is comprised of two numbers. It's one part interest and one part principal. All right. So you know that it's a 360 total payments, right? So it's a 30-year fixed mortgage that you're going to pay monthly. So that's 360 total payments. So if that's the case, your very last payment, your 360th payment, will be due August 28th, 2047. So what's the rest of all this say? Well, each one of these numbers going down are the specific payments. So for example, this number here, that's your 30th payment. Okay. On your 30th payment is due February 28th, 2020. The amount that you owe on your home based on a good payment record from the first payment to the 30th will be 238,588. You're going to write a check for 1,157.79. Of that, 745.59 will be interest, 412.20 will be principal, and at the end of that, that's the remaining balance. All right, so let's look at it. On your first payment, that's going to be due today. At the beginning of that day, today, you have not made any payments. So that means you owe a total 250, which is the total price of your home. Okay. So based on our calculations up top here, our regular payments 1,157, and of that regular payment, 781.25 is interest, 376.54 is principal. Remember that goes to reducing this amount. Okay. There is no extra payment this time, and the ending balance after all of this is 249,623.46. Now, like I talked to you in the interest and principal video, remember that there's a relationship of 1 to 1. So for every dollar that the interest goes down, the principal goes up. And you may notice that as we start to pay this down, okay, as this number of beginning balance is going down, the interest is going down as well. That's because, as we talked about, the interest is the periodic interest rate multiplied by the amount that you owe. Everything that's remaining goes to principal, which is why as this goes down, and principal goes up. And if everything in this amortization schedule works correctly, the very last payment, payment number 360, will resolve at a zero value. So at this point, hopefully you've read through the book. It starts on page 372 in your text, at least in the newest edition of the text. Those page numbers are subject to change depending on what volume of the book you have. Hopefully you understand the concepts now. So let's just talk about how do we figure this out in Excel. It takes about 5 minutes, maybe a little bit longer, depending on how good you are with functions and whatnot. But overall, it's really not too hard. So let's try this together. Oh my, there we go. So here we have the exact same thing that we looked at before solved, except it's completely blank. So the first thing we're going to need to do is jump over here to cell H4 and figure out how much our actual payment is going to be. So we're going to do PMT, And as we've talked about a million times, the first argument for PMT is rate. Rate stands for periodic interest rate. So I'm going to take that 3.75% and divide it by 12. All righty. The next argument for the PMT function is NPER. You know that stands for total number of periods. So it's a 30-year loan that you're making 12 payments a year on. So we're going to take 30 times 12, call that a day. And the present value argument of the PMT function is the amount that you're borrowing of the loan. That's going to be $250,000. We're going to plug it in like so. And that gives us a payment of $1,157.79. Now, the next little summary box here asks us for the total number of scheduled payments. Well, the total number of scheduled payments is 360, but there's no need to actually know how to do that. Why not just take the 30 years and you're making 12 payments a year and let Excel tell us there's 360 total payments, okay? Now, at this point, we'll plug in that zero value for extra payment. There's nothing else that you can fill out in the summary box. Before you can fill out the rest of the summary box, you're going to need to go down and actually complete the amortization schedule. So let's do that together. And I'll tell you, it really doesn't take all that much time. One thing that's missing in this one, it's kind of shrunk, is we need to expand column C there so you can see the beginning balance column there. Alrighty, so let's go through, okay? So we'll start with the payment number. So in this particular case, the first payment is number 1. All right. That being said, though, there's 360 total payments. So in column A, you need 1 through 360 going all the way down. Your biggest mistake would be to actually try to do that. 2, 3, 4. Gosh, that would take you forever, right? So please don't do that. You know that in Excel, there's always a faster way. So in this particular case, I'm going to use the fill option, specifically fill series, okay? So to get to fill series, I'm going to go to the home tab in the ribbon, editing group. I'm going to select fill, and I'm going to select series. Now from here, I want to fill the column, right? Column A, in increments of 1, stopping at 360. Click OK. Voila, 1 through 360, exactly where we want to be. Alrighty. Now, there's several different ways to get the dates to work, right? So we're saying that the first date that it is due is today. Your due date is today, September 28th, 2017. Now, there's many different ways to do this. All of them will be fine, whatever you know how to do. But I want to show you one easy way to do this using the fill handle. So I'm going to take today's date, 9/28. 2017. I'm just going to pop that in. Now, when I use the fill handle, I'm going to click it once, and it doesn't do what we want it to do. Instead of giving us the next month, October 28th, it gives us September 29th. Now, it does that because the fill handle adds 1 to every relative reference, as you know from way back in the beginning of the semester. And you also know that in the eyes of Excel, dates are just numbers like any other number. So if you add 1 to it, you simply get the next day. However, you can change that option by clicking the options box here and selecting fill months, like so. Now at that point, it goes September 28th, October 28th, double click the fill handle. Now we're talking, okay? So at this point, we can fill out the next box in the summary loan box, which is the normal payoff date. That's the date of your very last payment. So if we skip to the bottom, the normal payoff date is August 28th, 2047, okay? So I'm going to pop up here. I'm going to put in August 28th, 2047, all right? It's a pretty long way away. So the next cell that we need to figure out here is the beginning balance. Now this is really a tricky column because the beginning balance of every single payment is going to change, okay? So the beginning balance of the first payment is what you owe at the beginning, $250,000. However, the beginning balance of the second payment is going to be something less because you've made a payment, all right? Now we don't know what that's going to be yet, not a problem. We'll just start with row 1 and work our way down. So D13 is where we place our regular payment. Now you could write the payment function there, but there's no need because you've already done it. So why not just reference cell H4, and we're going to absolute reference that, call that a day. Not a problem. So now here's where it gets interesting. So there's two different ways to calculate the interest here. You could do it the business calculus way and take the periodic interest rate multiplied by the amount that you owe. Absolutely not a problem. If you don't know how to do it that way, or if the things that I've said don't make a ton of sense to you, which hopefully they do, there is another way to do that, and that is using the IPMT function, okay, as we discussed in the prior video. So we're going to use IPMT here by taking the periodic interest rate with the period of the payment number. So the period argument of the IPMT function will be the payment number that you're evaluating. So in this case, we're going to choose payment number 1, not absolute. Okay, we want that to fill down. The third argument that we're going to plug in is the total number of periods, which you've also already calculated is 360. We're going to absolute that as well. And the last argument we're going to plug in is the $250,000 purchase price, which also needs to be absolute. There is no carry forward amount at the end of the loan, and there is no, the type is not defined. So since the type is not defined, you leave that blank. The default value is 0. So we're going to close this off, and we're going to get the interest of $781.25. So far, so good. Now, for the next step, principal. Here, you could use the PPMT function, and that's not a problem at all. PPMT works just like IPMT. However, you know that since the interest is coming off the top of the regular payment, you could even make it easier by simply taking the regular payment minus whatever the interest is for that payment, and it'll give you the exact same answer as PPMT would. You're welcome to use either one. It's really just what works for you. Okay. So the extra payment, there is no extra payment here. However, we're going to reference that because it is important. Hopefully somewhere you've heard someone say that if you have a loan, if you make extra payments or pay above the normal minimal payment price, you will pay it off early. That is absolutely true, and I will show you that a little bit later on in this video. So we're not going to just ignore where it says extra payment. We're going to reference it even though there's nothing in there right now. So moving forward, if we need to, we can use that. Okay, so the ending balance of the first payment is going to be the beginning balance of that payment minus the principal minus any extra payment. No big deal there. Okay. Now we're almost done and we're almost ready for the magic of Excel to happen. Okay. The ending balance of the first payment is the beginning balance of the second payment. Haha. So now the magic can start to happen. Okay. So now we can use the fill handle and start letting this fill out. Okay. So we're going to fill this down. We're going to fill down the regular payment. We're going to fill down the interest, fill down the principal, fill down the extra payment, and last but not least, fill down the beginning balance. And all of that is magically done, okay? So in this particular case, the actual number of payments will be the original number of payments because we've paid it off, there we go, in 360 total payments like so. So there's the 360th payment, resolved at 0. So the actual number of payments and the scheduled number of payments in this case would be the same. Now you're probably asking yourself, at what point would these two dates be different? When would it not be 360 actual payments versus 360 scheduled payments? And when would it be August 28th, 2047 normal payoff date and not that date at the end? Well, the answer to that would be if there is an extra payment, which right now there isn't, but there could be, okay? So let me just go in and add a little function here to calculate that extra payment if I need to, okay? So let's say that at the end of every month, you make a payment, an extra payment of $500. When I do that, you may notice that that's $180,000 in extra payments on a $250,000 house, right? So that's a pretty good win. Now, that being said, watch what happens here. And this number actually would have to change a little bit. So watch what happens. So because I'm making this extra $500 payment, remember the bank takes their interest off the top. Okay. So no matter what, every month you'll write a check for 1,157.79. The bank's going to get that check. They're going to immediately subtract whatever the interest is. Whatever is remaining after that goes to reducing your beginning balance, which means that since the bank has already taken their cut, that extra 500 immediately goes to principal. So yes, you absolutely paid off early. So if I scroll down a little bit, eventually you'll see the numbers right about there go negative, right here at row 249. So what that means is you have actually paid your loan off early, almost a little over 130 payments early. Okay, that's what that extra $500 per month does for you. Here's some other things it does. It will save you, if you were to do that in this particular case, $24,326.26 in interest. So that's a huge savings to you by doing that. And also in that particular case, that would be when the actual payoff date, which would be right in here somewhere, right there, boom, right here, the actual payoff date of April 28th, 2037 would be different than the scheduled payment date of August 28th, 2047. Okay, so that's the difference if you make those payments. Okay, we'll put that back to 0. And to round this off, the last thing I want to talk to you about is the first thing that I talked to you about way back when, which is why do banks give loans? Well, the reason that banks give loans is because on this $250,000 loan at a 3.75% interest rate, the bank will be earning 166,804.03 in interest. Okay. So not only are they going to get back the 250,000, they're also going to get 166,804 for a total of $416,804.03 on a $250,000 house. Okay. So if you look at the principal column and you add that up, the principal column adds up to 250,000, which is what your original loan was. If you look at your interest column, the interest column adds up to 166,804.03, which is the amount that the bank is making off of you. Okay. And if you add those two things up, the total repayment that you're going to make on this loan is 416,804.03. That is why banks give loans. So I hope you've enjoyed this video. Amortization is really interesting and very, very much needed in the financial world. So my one key advice to you is please practice, practice, practice. It takes a little bit of practice in order to master this. I would say that there's a 100% chance that amortization will be on your final exam. If you have any questions about this or any other videos in the series, please call me, come by my office, shoot me an email, whatever you need to do. Until then, I will see you next time.